Alright, to do all the calculations that we need to do concerning curve mirror, we must introduce all the formulas that will help us to calculate whatever we are asked to calculate or whatever we are asked to find. Okay, so let's do the introduction. First of all, the ultimate formula for mirror, curve mirror, is what? 1 over mu plus 1 over v equal to 1 over f. Can you see that? That is the ultimate formula, okay? So this formula can also be rearranged as 1 over f equal to what? 1 over u plus 1 over v. You can also rearrange it like this, okay? Now, apart from this formula, we've talked about magnification, okay? So you need to check up on our video when we discuss about this. So, magnification, which is letter M, magnification is simply the ratio of what? The distance of the image, distance of image to the distance of the object. That is, this is the distance of what? Image to the mirror over the distance of object to the mirror. That is what magnification is all about. Alright? And magnification is also image height, okay? Image height, alright? Over what? Object height. Object what? Height. Do you understand that? So we can use image height over object height as our magnification. So when we now look at this whole thing, we discover that this formula can form part of our general equation. Alright? So these are the questions, these are the formulas you need to use to get your answers, okay? Alright, welcome back to the class. We want to quickly solve questions in relation to all the things that we have discussed. There are several questions there, and they are all wire and gram type of questions, okay? So I omitted all the options for this question for a reason. Probably just to have enough space so that I have all the questions written down. We can just quickly do that, and So let's start. The first one says, an object is placed 20 centimeters from a concrete mirror of a focal length 10 centimeters, right? The linear magnification of the object is, now we are looking for linear magnification, okay? So now let me use this page for solving the question. So the first one, the object is placed 20 centimeters, alright? So we use u for object. Object is called object height. We use u to represent that, okay? Then the focal length is what? 10 centimeters, okay? Isn't that focal length? The question is, what is the magnification? What is what? The magnification. So how do we get magnification? Remember, the formula for magnification is that the image height over object height or image distance over object distance. That is the distance of the image to the mirror, okay? So now, we don't have the image, but we have our focal length, okay? So you can just quickly apply this formula to get your what? Your image. So let's do 1 over f for a what? Remember, for a concrete mirror, everything is real, okay? The focal length is real, the image is real, depending on the position of the object. Are you getting it now? So 1 over u plus 1 over v. So what do we have? 1 over 10 equal to 1 over 20 plus 1 over v. So a very simple way to solve this is just find the LCM of all the denominators, alright? So the LCM of all the denominators is what? 20v, right? 20v, that's the LCM of 10 and 20 is what? 20, right? Then we have v, that's 20v. So 20v divided by 10, that's what? 2v. So multiply this one by 2v, that's 2v equal to now 20v divided by 20, that's what? V. Multiply this one by v, that's your v here. Plus 20v divided by v, that's 20. Multiply this one by 20, that's your 20 here. So we can now eliminate the denominator. You understand how this thing works, right? So we have 2v equal to what? V plus 20. Alright, so when this v comes here, now the 2v minus v equals to 20. So so that V is now 20 centimeters. Alright? So our multiplication is now what? 20 centimeters over 20. What do you have? 1. Now, if you notice, you can discover that what? Each object was placed at what? Times 2 of the focal length, which is what? The center of curvature. And if you watch the previous video, there's what? There is equal image when the object is placed at the what? Center of what? Curvature. You understand that? So, the next question, please. Now, number 2. Number 2 question, we have an object is placed 10 centimeters from a contact mirror of radius 2 centimeters, right? The image form is, so an object is placed what? Number 2 now. So object is 10 centimeters, right? And the radius is what? 32 centimeters. What kind of image will you form? Now let's look at this. So if the object is 10 centimeters, we need to discover what will be our focal length. So what is our focal length? Our focal length is half of the radius, okay? Half of the radius is what? 16. Right? Half of this 32 is 16. Okay? So focal length is what? R over 2. So that would be 16. Now, if an object is placed at 12 centimeters, it means actually if this is the focal length, and this is our center of curvature. The object was placed somewhere here between F and P. Can you see that? So it's placed, that is, between F and P, not even at F or between F and C or at C. Can you see that? So that means this object that was placed here, we now have the what? A real image. Remember, I've taught this in our previous video. You can go and watch that and understand it. So if you have a real image, the image will be sorry. If you have the virtual image, I mean, it will form behind the mirror, and this image that is virtual will be magnified, okay? Virtual and magnified, alright? That is it. Whenever the object is placed between F and P, so that's the virtual, magnified, upright image, okay? Virtual, magnified, upright image. Are you getting it? So, and it is behind the mirror. That's just the answer for that. That's the answer to that question, okay? So, you can still do a calculation to discover the position of what? The object. So, what will be the calculation? So, that will be what? 1 over F equal to 1 over U. Now, plus minus 1 over V. Now, the image is behind, and the focal length is also behind. Can you see? Focal length is behind, image is behind. So when you put all this, you have what? 1 over minus what? 12, sorry, 1 over 16 equal to 1 over what? 1 over 12 minus 1 over V. So, alright, so let's simplify this. What is the LCM? Alright, we can find the LCM. So our LCM will be what? 16 and 12, that will be what? If you use 4 here, that is 4, 3. Use another 4, that is 1, 3, and 3. So 16 times 3. 16 times 3, that will be 48, right? So our LCM is 48. So the LCM is 48, so we have 48Z because of this Z here. Alright, so 48Z divided by 16, that's 3. So that is minus 3Z. Okay? Remember your Z, right? 48Z divided by 12, that will be what? 48Z divided by, that's 4, right? 4Z. Now 48Z divided by Z, that will be 48. Okay? So when you simplify, what you have? Minus 3Z equal to what? 4Z minus 48. Okay? This is why that's 7Z. Can you see that? And if when 4 comes here, it becomes minus 4. Minus 3 minus 4. That is minus 7Z equal to minus 48. When you divide both sides, Z is now what? 48 over 7. So what will 48 over 7 give us? 7 and 42 should be 6, right? So 6, alright, 6 remainder what? Remainder 6 over 7. Okay, centimeter. 6 remainder 6 over 7 centimeter. Okay, can you see that? Alright, so now, that's just for number 2, okay? So now let's solve number 3. Now, number 3 says a concave mirror position at a 5 centimeter from an object is a linear magnification of 4. So number 3, we have magnification as 4. So a concave mirror position at a 5 centimeter from an object. So an object is 5 centimeter. Can you see that? Has a linear magnification of 4. Can you see that? Alright. So the next thing is what? The radius of curvature of the mirror is, so now we are looking for radius of curvature. Alright? And for you to get the radius of curvature, you know you have to what? You have to be able to do, alright, solve and get your focal length before you get your radius of curvature, because your radius of curvature is 2f. Okay? So how do you get 2f? First of all, start with this one. You know, magnification is what? Image over object. And we already have object. So our image is what? That will be 4 equal to image over object, which is 5 centimeters. You understand? We don't have image, right? So cross multiply, this is our what? 20 centimeters. So our image is 20 centimeters. So what will be our f? Our f will be 1 over f equal to, remember this is a concave, this is what? A concave mirror. So everything is positive, okay? Positive. So 1 over f, 1 over mu, you understand? 1 over mu. So what is our mu, please? 5. Plus 1 over v. What is our v? Our v is what? 20. So 1 over 20. So find the LCM of everything. That will be what? 20f. Alright? So 20f divided by f, that's 20 equal to 20f divided by 5. That's 4f. Plus 20f divided by 20. That's f, right? So what do we have? So that's 20 equal to 5f. Alright? So f is equal to what? 20 over 5. And that is 4. That is what? 4. So our focal length is 4. Therefore, our radius of curvature is 2 times 4, which is equals 8 centimeters. So the radius of curvature of that mirror is 8 centimeters. I hope you understand. Alright? So now let's continue. The fifth question, now sorry. I think the fourth question now. Number 4. An object of height 2.5. So what is the height? You can also use v to represent the height. So number 4. U to represent the height of the object. That's 2.5 centimeters. An object of 2.5 centimeters position 10 centimeters from a concave mirror. 10 centimeters from a concave mirror. What happens? So this is an image 30 centimeters from the mirror. 30 centimeters, wow. 30 centimeters from the mirror. So remember, an object of height, this is height, object height. So let's use UH for object height. Alright? Position 10 centimeters. 10 centimeters from what? The object mirror. So the object distance is what? 10 centimeters. This U is just object height, okay? So the object distance is just 10 centimeters. Alright? So this is an image of 30 centimeters from the mirror, okay? So the image is 30 centimeters, alright? So the height of the image is, so we are now looking for image height, okay? Image height. Now, this is the simplest of all, alright? So what is magnification? Magnification is what? Image distance over object distance also equal to what? Image height over what? Object height. So you just equate all these values and you get this one. As simple as anything. So let's do that. So we have what? Our V is 30 over our V is 10 equal to what? VH is what? The one we are looking for over what? 2.5. 2.5 cross multiply V is equal to 30 times 2.5. Okay? So you have your 10 here. So divide both sides by 10. So V is equal to 30 times 2.5 over 10. So this 0 will actually 0. 10 times 2.5. That is what? 7.5. So our V is 7.5. The height of the image is 7.5 centimeters. Is that okay? So let's go to number 5. Okay? I hope you can see the question. Alright. Number 5 question. Number 5, a pin is positioned at 21 centimeters from the positive zero. So, object is 21 centimeters. 21 centimeters from the positive zero. Of radius 28 centimeters. So, R is 28 centimeters. Can you see that? The magnification of the image form is, so we are looking for magnification of the image form. Can you see? So you have all this and you're looking for magnification. Now, this time around, I want to solve it in another style. Okay? Now, what is the style I want to do? Since we are looking for magnification, I'm going to factor in magnification into the main formula. Okay? Alright, first of all, our air is half of this. And half of this is 14 centimeters. Is that correct? Good. So now, 1 over f, remember this is what? A constant mirror. So everything is positive. Your f is positive in front of the mirror. And your image is positive. Of course, everything is positive. So what do you have? 1 over f, 1 over u plus 1 over v. Okay? Now, m is what? V over u. So now when you cross multiply, V is what? MU. Can you see? V is MU when you cross multiply this, alright? So when you take your MU and slot into this place, what would that give you? That would give us 1 over F equal to what? 1 over mu plus MU. 1 over MU, okay? Alright, so let's put our value. So 1 over 14 equal to 1 over u. What is u? 21 plus 1 over mu. What is m? Okay, we're looking for m. What is our u? 21. So 21 m. You get that? 21 m, alright? So what is the LCM? The LCM is okay, the LCM is 2 times 21, that's 42, right? The LCM is 42m, okay? Now 42m divided by 14, that will give you 7. So this one is 7. 7 times 1, that's 7. Equal to 42m, alright, divided by 21. Am I 42 divided by that? Wait, I want to be sure that this my calculation is correct. Okay, I just did it now. Alright, so it's not 7, this is 3, okay? Alright, 3. This is 3. Now 42 divided by 21. Let's try that. 42 divided by 21. 7 years 3, 7 years how many? 6, 3 years. Okay, so 2, this one is 2 plus, alright? Okay, this is supposed to be 3m. Alright, that's 3m. This is 2m plus this is what? 2 only. I want to get that now. So when you simplify this, what do you have? So this is 3m equal to 2m plus 2. This is your 2m to that side. That's 3m minus 2m equal to 2. So m is equal to 2. The magnification is 2. You see how I just went straight. Instead of finding my image, then doing image over object. So I just plot in the substitution like this so that I can quickly solve the question. I hope you can do that also. So now, number 6. Now, I have 7 questions. Number 6 will be my last question because I want you to also attempt to number 7. So, number 6, I have, this is convex mirror, very interesting. So remember when we talk about convex mirror, you know, your image is negative and your f is negative. Those two are negative. So let's do. So a convex mirror produces an image which is 1/4 the size of an object. 1/4. That is the magnification. Okay, so let's write that down. So when you get 1/4 the size of the object, to have the size of the object, you know, the size of object, the ratio to the size of the object, that is magnification. So magnification is 1/4. 1/4. Look at it. Alright, this is quarter, okay? The size of the object. Alright, that's our magnification. So what do you have? In front of it. If the convex mirror produces an image which is 1/4 the size of the object. If the radius of curvature of the mirror is 32. So our R is 32. The distance between the object and its image is now we're looking for distance between object and image. Please. So if this is object and this is, let's say if this is object, yes, and this is image, we're looking for the distance. Remember, in between you have your mirror. So this is the mirror, right? Okay? So what is F here? F is what? 16, right? How do you solve this question? How do you solve this question? Look at it. The object mirror produces a unit which is what? Or water the size of an object placed in front of it, right? If the radius of curvature of the mirror is 32, the distance between the object and its image. Look at this. You can see this technical. Wow. Okay, so now what this is I have, what can I get from it? I can use this to get the image or the object, right? I can use it to get the image of it. How? If you do the same thing, the one I did before, right? So let's try. So 1 over minus n. Why minus n? You know, the n is behind the mirror, so it's minus, right? Equal to 1 over nu, no, sorry, minus 1 over mu. Why minus v? Because that one is also, the image is also behind the mirror. You understand? Remember, this is image. Okay, this is object. Okay. Alright, so now let's continue. So if our n is equal to, our n is v over u, plus multiply v is what? N mu. So you take this and put inside here. So you have minus 1 over n equal to 1 over u minus 1 over n mu. Alright? So you can now put your values here. So what we have, our value for f is what? 16. So minus 1 over 16 equal to 1 over u. We don't have u actually. Alright? So minus 1 over, our multiplication is, what do you call it? 1/4. Alright? Or quarter. So that is 1 over 4 what? U. Alright? So you can simplify this. This 1 over 4, when you simplify it, that will give you what? Minus 1 over 16 equal to 1 over u minus, this is 4 over u. How? 1 over 4, sorry, 1 divided by 1 over 4 u. When you say 1 times, this 4 will come up, u will come down, that's what? 4 over u. Can you see that? Alright, so that is why we have 4 over u here. Do you understand this? Alright? Okay, so now what we have? Just LCM. LCM is what? 16 u, right? So 16 u divided by 16, and that's minus u, right? Equal to 16 u divided by u. That is 16 minus 16 u divided by 4. That is what? 16 u divided by u, that's 16. 16 times 4, that's 64. Okay? Can you see that? So, I have simplified it out, minus u equal to 16 minus 64. What would that give you? That would give you 64 minus 16. Okay, 8. Alright? This is 5. 5 minus 1, that's 48. Okay? So this is minus 48 minus 8. So u is what? 48. Can you see that? 48 centimeters. So we got our u at 48 centimeters. So the distance from here to this place is 48 centimeters. Now, what is the distance from here to here? Okay? Now that will be the distance of image. And distance of image, remember our image from this formula, our image is what? Mu. So what is M? 1 over 4 times 48. 1 over 4 times 48, that will give you what? 4 here 1, 4 here is what? 1, 2, 12. So 12 centimeters. So if from here to here is 48 centimeters, and from here to here is what? 12 centimeters. When you add both, that will be what? 48 plus 12, that is 60 centimeters. Do you understand? We are looking for distance between image and, sorry, object and image. Object and image. So object distance is 48, image distance is 12. From here to here will be 60. I hope you get that. Now, the last question is, the image of the object OY formed by the mirror is, now look at the mirror here. This is my mirror here. Okay, this is my focal point. This is my center of curvature. So when an image is placed in between center of curvature and focal length, how would the image look like? Remember, this is what? Is it concave or convex? You can check that and you can now tell me where the image is from, okay? Where will the image from? Is it behind or in front? Is it a real image? Is it inverted? What is the position exactly? Please drop this at the comment section to help me to know if you understand what I've taught so far. Thank you.